catalyst is a substance which is used to alter the rate of the reaction, whether it is increases or decreases. If it increases the rate of the reaction, it is called as positive. When you add catalyst, chemical equilibrium attain very fast, it is very quick, but chemical equilibrium constant remain same. The two factors which gives effective collision, one is energy barrier, another one is what? Orientation barrier. Hello, my dear students. I am Renuka Ashok, Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. Today, the last session of chapter Chemical Kinetics, that is session 6. In the previous session, that is in the 5th session, I discussed about temperature dependence of the rate of a reaction, Arrhenius equation, activation energy, and qualitative increase in reaction rate with temperature. Last class, I discussed about what's the effect of temperature on the rate of reaction by plotting a graph of Ne by Nt versus kinetic energy. Ne by Nt means fraction of molecules having energy E, as well as I discussed about activation energy, Arrhenius equation. In this session, I am going to explain what's the effect of catalyst on the rate of reaction and collision theory of a chemical reaction. This collision theory is also called as Arrhenius theory. It is also called as what? Arrhenius theory. And have to discuss about effective collisions. Therefore, together with I am going to solve some problems which is related with Arrhenius equation at two temperature T1 and T2. Therefore, today in the last session of chapter Chemical Kinetics, I am going to discuss about what's the effect of catalyst on the rate of reaction, collision theory, effective collisions, as well as what? Problems. First, I will solve problems. On the equation, already you know that the velocity constants K2 and K1 at temperature T2 and T1 is related by using equation okay. My dear student, please observe the equation of formula on the board. Log K2 by K1 to the base 10 is equal to EA by 2.303 R into T2 minus T1 divided by T2 T1, where T1 is the initial temperature, T2 is the final temperature, K1 is the velocity constant at T1, K2 is the velocity constant at T2, EA is activation energy, R is universal gas constant. Now, please read the question. If the rate constant for a reaction, K1, the first one is K1, rate constant, 1.6 into 10 to the power of minus 5 per second and 6.36 into 10 to the power of minus 3 per second at temperature 600 Kelvin and 700 Kelvin. The first temperature is T1, the second temperature is T2. You have to calculate energy of activation, that is EA, and R value is given. R is equal to 8.314 joule per Kelvin per mole. Now, write down K1 is equal to 1.6 into 10 to the power of minus 5 per second. K2 is equal to 6.36 into 10 to the power of minus 3 per second. T1 is 600 Kelvin. T2 is 700 Kelvin. You have to calculate EA, activation energy. R is equal to 8.314 joule per Kelvin per mole. R is equal to 8.314 joule per Kelvin per mole. Log K2 by K1. What is the value of K2? 6.36 into 10 to the power of minus 3 divided by K1 is 1.6 into 10 to the power of minus 5 is equal to EA, have to calculate EA, EA by 2.303 into 8.314, T2 minus T1, 700 minus 600 divided by 700 into 600. 700 into 600. See, my children. So, what's the formula I am going to use for this? Activation energy is calculated by using Arrhenius equation at two temperatures T1 and T2. What's the formula? Log K2 by K1 is equal to EA by 2.303 into R into T2 minus T1 divided by T2 T1. I am substituting the values, and if I am going to substitute 10 to the power of minus 5, if it goes to numerator, it will become 10 to the power of what? Plus 5. Okay. And if you simplify 6.36 divided by 1.6, you have to simplify this. 6.36 divided by 1.6. It is 3.975 into, if 10 to the power of minus 5 goes to the numerator, it will become 10 to the power of plus 5. Here it is 10 to the power of minus 3, it will become 10 square. Now, EA into 700 minus 600, it is 100. 2.303 into 8.314 into 700 into 600. 700 into 600. Now, when you take the log for this, the value will become 2.5993. What's the value of log of this? You have to see log in your class table or log table. So, what's the log value for this? 2.5993, which is equal to EA into 100 divided by, if you multiply this is 19.147 into 700 into 600. Now, if you want EA, you cross multiply this 2.5993 into 19.147 into 700 into 600 divided by 100. Okay. So, EA is equal to, if you cross multiply this 2.5993 into 19.147 into 700 into 600 divided by this 100. If you calculate this, it will become 209.0 kilojoule, 209.0 kilojoule, or if you want to express in terms of joule, it is 209028 209028.9 joule, 209028.9 joule. If you convert into same into kilojoule, it will become what? 209 kilojoule. So, this is how do you calculate activation energy by using K2, by using K1, T2, T1 as well as R. R is always constant, its value is always 8.314 joule per Kelvin per mole. Okay. Next problem, read the problem. The rate constant of a first order reaction become how many times? 5 times when the temperature raised from 350 Kelvin to 400 Kelvin. Calculate the energy of activation. The first order rate constant becomes 5 times. That is, when K2 is 5 times of the K1, K2 is equal to 5 times of K1. Therefore, K2 by K1 is equal to 5. K2 by K1 is equal to 5. T is equal to, T1 is equal to 350 Kelvin. T2 is equal to 400 Kelvin. EA is equal to question mark. R is equal to 8.314 joule per Kelvin per mole. So, why I had written K2 by K1 is equal to 5. Here in your problem data is the first order reaction, the rate constant become 5 times. How many times? 5 times. Therefore, the ratio of K2 and K1 is equal to 5. Take equation formula K2 by K1 to the base 10 is equal to EA by 2.303 R into T2 minus T1 divided by T2 T1 log K2 by K1 is 5 to the base 10 is equal to EA by 2.303 into R is 8.314 into T2 is, what's the T2 value? 400 minus 350 divided by 400 into 350. 400 into 350. Okay. Log 5 is 0.6990 is equal to EA by product of this is 19.147. 19.147. Always, my dear student, remember the product of these two, because in every problem as well as for your competitive concern also, the product of 2.303 into 8.314 is always 19.147. 19.147. It is 50 divided by 400 into 350. Now we want EA. EA is equal to 0.6990 into 19.147 into 400 into 350 divided by 50. Divided by 50. If you simplify this, so you will get the answer 37474.5 joule. 37474.5 joule. Here the very important point is you have to take K2 by K1 is equal to 5. K2 by K1 is equal to 5. What's the formula we have to use? Log K2 by K1 to the base 10 is equal to EA by 2.303 R into T2 minus T1 divided by T2, T1. Next problem. The first order rate constant for the decomposition of ethyl iodide by the reaction at 600 Kelvin is 1.60 into 10. Therefore, K1 is 1.60 into 10 to the power of minus 4 5 second at temperature T1 600 Kelvin. EA 209 kilojoule per mole. If you convert into 209 into 10 to the power of 3 joule per mole, rate constant at 700 Kelvin, you have to find out K2. T2 is 700 Kelvin. Here we have to calculate K2. Here you have to calculate what? K2. What's the formula you have? Log K2 by K1 to the base 10 is equal to EA by 2.303 R into T2 minus T1 divided by T2 T1. Log, you have to find out K2. K1 is 1.60 into 10 to the power of minus 5. EA is 209 into 10 to the power of 3. This is 2.303 into 8.314. This is T2 is 700. T1 is 600. This is 700 into 600. 700 into 600. You have to calculate K2 value. So, after simplifying this log value and right side log K2 by 1.60 into 10 to the power of minus 5. When you simplify the right side, you will get 2.5989. What is the answer for right side? 2.5989. When log goes to RHS, it will become anti-log. It will become anti-log. Therefore, anti-log of 2.5989. 2.5989. After simplifying all these things, you will get K2 value as 6.3552 into 10 to the power of minus 5 second. What's the K2 value? 6.3552 into 10 to the power of minus 5. Here, by using EA, T2, T1 as well as by using K1, had calculated the value of what? K2. Anti-logarithm table. Effect of catalyst on the rate of reaction. What is the effect of catalyst on the rate of reaction? Before that, I will define what is catalyst. Catalyst is a substance which is used to alter the rate of the reaction, whether it is increases or decreases. If it increases the rate of the reaction, it is called as positive catalyst. If it decreases the rate of reaction, it is called as what? Negative catalyst. But Catalyst alters the velocity of the reaction, but it does not without itself undergoing any permanent chemical change. It does not undergo any permanent chemical change. It may undergo some physical change, maybe crystalline. If it is in the form of crystalline, it may convert it into amorphous, but it does not undergo any chemical change. Therefore, what's the definition? Therefore, my dear student, don't think that catalysts are used to increase the velocity of the reaction. Catalysts are required to increase the velocity as well as decrease the velocity. Therefore, in catalyst definition, I'll use term which alters. Alter means which increases or decreases without itself undergoing any chemical change. For example, decomposition of potassium chlorate, decomposition of potassium chlorate, decomposition of potassium chlorate to potassium chloride and oxygen, which is catalyst. Manganese dioxide is catalyst. It is a positive catalyst. It's a positive catalyst. Therefore, it increases the rate of the reaction. My dear students, what's the definition for catalyst? Catalyst is a substance which alters the rate of the reaction without itself undergoing any permanent chemical change. So, how this catalyst affects the rate of the reaction? It can be studied by using one theory that is called as what? Intermediate complex theory. Intermediate complex theory. Now, when I will consider reaction A and B, reactants give rise to product C and D, I am not going to use any catalyst. But I will repeat the same reaction in the presence of catalyst X. Let us consider a chemical reaction A plus B give rise to C and D in the absence of catalyst. I will repeat the same reaction in the presence of catalyst X. What happens? The reactants form a temporary bonds with catalyst and there is an existence of transition state. Existence of what? Transition state. What is X here? X is the catalyst. X is the catalyst. This catalyst form temporary bonds or they are partially bonded with reactant and there is a formation of transition state, or it is also called as intermediate complex, or it is also called as what? Intermediate complex, or it is called as what? Transition state. This transition state is unstable and it gives rise to product with regeneration of catalyst X. With regeneration of catalyst X. Therefore, please read this. According to this theory, a catalyst participates in the chemical reaction by forming temporary bonds with reactant resulting in intermediate complex. This has a transitory existence, decomposes to yield product and the catalyst. So, the catalyst, although here involved in the reaction, forming a temporary bonds with reactants A and B, after decomposition, it is regenerated. That's why it does not undergo any permanent chemical change. Therefore, when we use catalyst X, the reactants are not directly converted into product. The reactants are react with catalyst and they'll form temporary bonds or partial bonding with reactants and they'll form transition state or intermediate complex. It is a transitory existence or it is unstable. Hence, it decomposes to form product with the regeneration of the catalyst X. Now, it can be explained by using graph of potential energy versus reaction coordinate. I'll use which graph? Potential energy versus reaction coordinate. This is the graph obtained for reaction path without catalyst. Now, I'll repeat the same reaction in the presence of catalyst X. What you observed? This energy hill or energy barrier, the height decreases. Height decreases. This is a EA2. EA2. This height is what? This height is what? EA1. EA1 is the energy of activation with catalyst, this height. And this is energy of activation without catalyst. This graph without catalyst. This graph with catalyst. With catalyst, what happens? When you add catalyst, this height of energy hill decreases. Hence, its activation decreases. Velocity increases. Height decreases. EA also decreases. Velocity increases. Therefore, what happens when you add catalyst to the chemical reaction? Catalyst provides an alternate pathway to the mechanism by reducing the activation energy. Therefore, when catalyst is involving, which energies take part? So, they'll ask in multiple choice question, they'll ask which energy is involved? Threshold energy, activation energy, kinetic energy, potential energy. Which energy is involved when catalyst is involved? That is known as what? Activation energy between reactants and product, hence lowering the potential energy barrier. This potential energy barrier decreases. Energy height decreases. As height decreases, activation height is directly proportional to activation energy and it is inversely proportional to what? Velocity. Therefore, what happens when you add catalyst to the chemical reaction? It decreases the potential energy barrier or energy hill barrier height decreases, activation energy decreases and velocity increases. Therefore, when you add catalyst to any chemical reaction, which energies get decreases? Activation energy decreases, velocity increases. Therefore, what's the relationship between activation energy and velocity? Activation energy and velocity are inversely proportional to each other. They are inversely proportional to each other. Next, when you consider this effect of catalyst, for example, what are the character of catalyst? So, you have taken reactants in large quantity. No need to add catalyst in also large quantity. A small amount of catalyst can catalyze the large amount of reactant. The catalyst does not alter the free energy change. Delta G will become 0 as well as delta H also becomes 0. So, when you add catalyst to any chemical reaction, two thermodynamic quantities like change in free energy and change in enthalpy, that is delta G is change in free energy, delta H is change in enthalpy, they become 0. A catalyst can catalyze the spontaneous reaction but does not catalyze non-spontaneous reaction. As you know, in thermodynamics last year we studied about two types of reaction, spontaneous reaction and non-spontaneous reaction. What are spontaneous reaction? Which takes place on its own. For example, rusting of iron, melting of ice, it takes place on its own. Iga iron rust idiyadu, ice melt agadu, tanna padige taan agutte. Tanna padige taan aguvanta reactions na navenanta kariತೀವಿ spontaneous. Some reaction does not take place on its own. They need external aid, they need external support. Such reactions are known as what? Non-spontaneous reaction. Non-spontaneous reactions na catalyze madalla. They catalyze only yav reactions? So, spontaneous reaction. And a catalyst helps in attaining the equilibrium quicker, but it catalyzes both forward and backward reaction in the same extent. Therefore, equilibrium state remains same, but it is reached earlier. So, when you add catalyst, chemical equilibrium attain very fast. It is very quick, but chemical equilibrium constant remains same. These are the characters of catalyst. Last part of this chapter, collision theory. According to collision theory, the molecules of this are considered as hard spheres. According to theory, reactant molecules are considered as what? Hard sphere, and these hard sphere must undergo two types of collision. When they properly collide with each other, it is called as effective collision. When just it touch, it is called as what? Ineffective collisions. Therefore, according to Arrhenius, the reactant molecules are called as hard sphere and they undergo effective collisions. See, my children, according to theory, the reactant molecules are assumed to be hard sphere and the reaction is postulated to occur when molecules are collide with each other. So, when the number of collision per second per unit volume of the reaction is called as collision frequency. Here using one terminology that is known as what? Collision frequency. What is collision frequency? Number of effective collision per unit time and per unit volume is called as collision frequency Z. When you consider bimolecular elementary reaction A plus B give rise to product, its rate is given by rate is equal to ZAB into e to the power of minus EA by RT. What is ZAB? ZAB is collision frequency, reactants A and B. E to the power of minus EA RT represents the fraction of molecules with energy equal to or greater than. These are fraction of molecules. It is fraction of molecules whose energy equal to EA or greater than EA, equal to EA or greater than EA, equal to EA or it is greater than EA. Therefore, according to Arrhenius, the reactant molecules are considered as hard sphere. They must undergo effective collision. How many collisions are possible per unit time in unit volume? That is called as collision frequency. That collision frequency is denoted by notation Z as well as the rate of bimolecular elementary reaction. What's the bimolecular? Two reacting species are involving. What's the meaning of elementary? Which the reaction takes place in single step. Such reactions are called as elementary. For that, rate is equal to ZAB into e to the power of minus A by RT. Effective collisions are those which lead to the formation of product. The number of effective collision is governed by two factors. What are the two factors to require for effective collision? First one, the molecules are properly oriented. The molecules must be properly oriented. Observe here, methyl bromide reacts with potassium hydroxide, it gives rise to methyl alcohol. Here there is no formation of product because it is improper orientation. The molecules or atoms are not properly oriented. Here there is a formation of product because it is properly oriented. Therefore, orientation barrier. The reactant molecule must collide with favorite orientation in order to facilitate the breaking of old bond and formation of new bond. A molecule must be properly oriented. Next, the collisions are effective only when the molecule possesses energy greater than or equal to the threshold energy. Okay. So therefore, the two factors which gives effective collision, one is energy barrier, another one is what? Orientation barrier. Energy barrier, the collisions are effective only when the molecule possesses energy greater than or equal to the threshold energy. Orientation barrier, the reactant molecules are properly oriented. For example, formation of methanol from bromoethane depends upon the orientation. In the first one, it is improper orientation, therefore there is no formation of product. In the second case, the molecules are properly oriented, therefore there is a formation of product. Therefore, what are the two conditions for effective collision? The two conditions for effective collision, first one, the molecules are properly oriented. For example, ನೀವು ಲಾಂಗ್ ಜರ್ನಿ ಮಾಡಬೇಕು ಅನ್ಕೊಂಡಾಗ ನಿಮಗೆ ಬಸ್ ಆರ್ ಟ್ರೈನ್ ಅಲ್ಲಿ ಟ್ರಾವೆಲ್ ಮಾಡ್ತಾ ಇದ್ದೀರಾ ಅಂದ್ರೆ ಫಸ್ಟ್ ಸೀಟ್ ಪರ್ಫೆಕ್ಟ್ ಆಗಿ ಸಿಗಬೇಕು. ಅದಕ್ಕೆ ನೀವು ಮುಂಚೆನೇ ಏನು ಮಾಡಿರ್ತೀರಾ, ರಿಸರ್ವ್ ಮಾಡಿರ್ತೀರಾ. ವೆನ್ ಯು ಆರ್ ಪ್ರಾಪರ್ಲಿ ಓರಿಯೆಂಟೆಡ್, ದ ಜರ್ನಿ is comfortable. Like here also, when molecules are properly oriented, there is a formation of what? Product. As well as they must possess energy which is greater than or equal to threshold energy, then only effective collisions are possible. These are the two conditions for a molecule to undergo effective collision. When you consider the proper orientation of reactant molecule lead to bond product, improper orientation make them simply bounce back, products are not formed. To count for effective collision, another factor P called probability or steric factor. P is called as probability or steric. Already we have equation what? Rate is equal to ZAB. ZAB into e to the power of minus EA by RT. To that I am going to introduce a P. P is called as what? Probability or steric factor. Therefore, rate become P into ZAB into e to the power of minus EA by RT. Thus, in collision theory, activation energy and proper orientation of the molecules together determine the criteria for effective collision. Hence the rate of chemical reaction. Therefore, according to collision, the reactants are converted into product when they are properly oriented, as well as activation energy and proper orientation are the two criteria for a molecule to undergo effective collision. 6 sessions I tried to complete it and give all the concepts about what? Chemical kinetics chapter. Thank you. Goodbye.